as well. By using this system, we can collect that data from all customer, which is installed in Newton all over the world, and diagnose it before failure happens. Okay. Okay, then from this slide, Newton successfully achieved that high energy efficiency. This point I'd like to describe you. This is one of the example of the replacement case. Replacement from R22 unit to ammonia CO2 system. This storage volume is 45,000 cubic meter. And then originally they used that 8 set of ammonia, R22 unit before replacement. And then this small graph shows that energy consumption month by month, and then we compare this energy consumption between before replacement and then after replacement. And then you can see that in conclusion, successfully electrical bill itself of the customer has been deducted down to 31% compared to before replacement. Not only this customer, many customer which installed that almost all customer which is installed that Newton system can achieve that this much energy reduction. Okay. Okay. According to our study, this is a result of the comparison between the R22 and the Newton system and the ammonia brine system. X-axis shows that the tonnage of the warehouse, and then Y-axis shows that the specific power consumption in kilowatt-hour, tonnage, and then year. Here, power consumption includes that everything, not only equipment, but also lift, and then lights, and then offices, etc. From this graph, we can say that bigger warehouse has a lower specific power consumption because of that lower heat loss is there. And there cooling type indicated. Blue dot is R22, and then green dot is ammonia brine system, and the red one is Newton system. You can see that the ammonia CO2 brine system is about 25% lower than R22, and then 50% lower than ammonia brine system. Okay, then we started to introduce that this Newton system to abroad, outside of Japan also. Then Thailand, we already have like this history, and okay, this picture shows that the example of the installation. You can see this inside of this cold storage. It's very simple. Okay, then I'd like to describe you that the lineup of the Newton system. As I mentioned that we have 8 lineups, and then for cold storage, we have 3 lineups. Newton R and then Newton R 3000 and then Newton R 6000, Newton R 8000. This one is suitable for the F-class cold storage at minus 25, and then 3000 ton, and then 6000 metric ton, and then 8000 metric ton. And then for anteroom and then chill room, we have Newton C. And then Newton F, 300, 600, 800 is prepared for freezers. And then for scattering, we also have Newton S. Okay, then we just started to introduce this Newton system from Japan, not only from Japan. We started to manufacture this Newton system in US factory and then Brazil factory. We already installed that 800 set in Japan, and then gradually we are expanding to the another country from Japan. That's it. Thank you very much.
Thank you, Mr. Fujimoto. Since he has to leave to the airport urgently, I'd like to give some questions. I request Mr. Fujimoto to take a few questions, 2, 3 questions before he leaves. Then we can continue our session with the rest of the speakers. Since his company has been working on setting up a carbon dioxide-based refrigeration system. Well, it's a combination of carbon dioxide with ammonia. Ammonia is used, as he was telling, ammonia is used as a primary refrigerant, and carbon dioxide is used as a secondary refrigerant. The very nature of carbon dioxide is it's a very low pressure refrigerant, so which works very well below minus 30 degrees centigrade applications, for the freezing applications, for cryogenic kind of applications, for especially for the food processing industry, blast freezers, cryogenic freezers, and IQFs, and so on and so forth. It works very well, and low temperature cold storages. Now we have a choice, we have an option. In coming days are challenging for us because the environmental regulations, we have to comply with the environmental regulations. We are the signatory of the protocol that's been signed in France quite recently by Government of India. So slowly the refrigerants, the CFC has gone, HCFC is moving out. So there is a choice. Alternative refrigerants are getting replaced in place of HCFC, or 404A, or 407C, or 5047C. A lot of refrigerants are coming. But which is the real choice for us? Whether it's a Freon refrigerant, HCFC-based refrigerant, or it is an ammonia-based refrigerant, or new emerging solutions like carbon dioxide. Carbon dioxide is being used quite extensively, and it has been proven for very various reasons outside. Of course, in Scandinavia, it's quite extensively used, and Japan it has been used. Now, looking at the developments that is happening in the outside the country, how do we foresee the future, especially for the industrial refrigeration systems, especially in the food processing industry, especially in the low temperature applications? Mr. Fujimoto, could you please tell us how do you see Indian market with regard to using carbon dioxide as a refrigeration systems?
Use this?
No, you can speak.
Can you hear me? Now we are expecting that this ammonia CO2 system to install that several cold storages because that India market have some huge potential to grow up. So we are now keen on that this system. Not only this ammonia CO2 system, we are focused on another products which already introduced you, like some that hot water supplying system, which is called that Unimo system. We have many options to supply that customer by using that CO2 refrigerant. That is our expectation. Then we are now trying to expand this CO2 refrigerant and then another natural refrigerant to this market.
How safe is carbon dioxide to be used in the industrial refrigeration systems, and what kind of safety measures you are providing it in the installations?
Yeah, I think I already introduced you that some comparison of some each refrigerant. Okay, that as I said that ammonia sometimes some person is kind of the toxic or some dangerous, but CO2 is sometimes some CO2 also have some trouble in case of that leaked inside of the closed spaces. But same as ammonia, we have to equip that some safety equipment, and we have to do that appropriately control system. By using this, we can use this CO2 system safely. So, but compared to ammonia, in case compared to ammonia, we have I think we that CO2 carbon dioxide refrigerant is more safe than that CO2 system, I assume.
Okay, since these carbon dioxide based refrigeration systems especially are quite popular outside, both in terms of operation costs, both installation of the investment cost is quite high right now at the moment in India, and the concept is being promoted not only from the energy point of view, but also from the operating point of view, which is the major attraction in this kind of technology. And they've been talking about substantial amount of cost reduction, operating reduction, both in full load operation as well as in part load operation. Mr. Fujimoto, could you please just throw some points on to the audience on how comparatively in terms of percentage of savings probably could occur vis-a-vis with ammonia refrigeration system and with the with the HFC refrigeration, CFC refrigeration system for the same operating conditions? Yeah, it is a percentage.
Yeah, this point I already I also described you in inside of the presentation. We already successfully deducted that
Could you please
31%.
elaborate? Highly, because we are all sleeping during that time. Could you
Okay.
please
Okay.
could you please just
Yeah, yeah. 30% is average. Deduction ratio when the customer use that ammonia CO2 system, which I introduced you. That is, actual electrical city bill. So that reason that we can, say that 30% you can deduct. So in some case, that the customer can reduce that 40% up to 40% reduction successfully achieved. That is our study.
30% saving, right?
Actual power cost. We compare that the actual power bill, which is paying that actually paying that the customer to the electrical company. We are comparing that this actual bill to actual bill.
So it is 30%, right? It's
30%.
30%. Okay.
I have side. Maybe in Japan they increase the power tariff.
As per my experience, Indian electricity cost is same as Japan. That's true.
I have a small question to you. Is it the same for any ammonia CO2 system, or is it something to do with the specific to your Newton system, what you have shown over here? Is this power saving specific to all ammonia CO2 system, or something very specific to your Newton system which you have displayed? Is it something to do with Newton system, what you are brought out, or is it to do with any ammonia and CO2 system? CO2. Yes.
Okay, we are continuously trying to develop our products by using that natural refrigerant. For trying to develop that some natural refrigerant system, we developed that some another system which is using that ammonia CO2 system. But we continuously call that system is Newton. But Newton is now continuously developing. So the efficiency itself is increasing. But, okay, but we are from for 10 years, for 10 to 20, 15 years. 15 years we are continuously developing this ammonia CO2 system in Japan.
Thank you, Mr. Fujimoto. Any questions from the audience to Mr. Fujimoto? Any questions? It's more on a technology based. Please feel free to ask more questions to him. He has to leave in another 5 minutes. Please, could you please ask some questions to him? Check.
Yeah. Do you have a standalone CO2 system? Do you have anything only CO2 on CO2 systems? Not ammonia plus CO2.
We have. Okay. We are now trying to develop that CO2. We already developed that CO2 chiller, which is using for the cold storage. We already developed, but we are now selling in Japan only. So, I think in near future we can introduce you that CO2 only system to your country. But now, we are now keen on that ammonia CO2 system, to introduce the ammonia CO2 system to your, to your market. Because of that, we successfully, achieved that 31% electrical bill deduction. So that reason. But now we are, doing the actual activity in Japan. We already to start to supplying that only CO2 system, as I said.
Why not India?
Because there is, I think, in case of that, we have to take care that the machine from nearby a factory. We want to, first of all, we want to do that, take care that new machine nearby a factory, because of that, in case of that something trouble has happened, we want to take care of that, right?
No, actually-
After go through that entire experience, we will go out from the Japan. That is our procedure. So that reason.
Working pressures are also a little difficult to handle. Like we are in a tropical climate. When CO2 goes to a very high pressure level, so it cannot be used as a single CO2 system is little difficult, because in our ambient, if there is a power cut or something, it goes up to maybe
30 bar,
30 bar or 40 bar. So then your vessels and all those things needs to be designed according to it. So it's better to have a combination of, like CO2 is better in the negative range. Like once it goes to minus 20 and below, then the CO2 system is better.
Okay, thank you.
Additionally, I think CO2 brine system is suitable for the existing normal system, because that, as he said, that if brine, that pressure maybe goes to 15 bar only. So you can apply that this CO2 brine system to the present condition. So that's why we are introducing you that this ammonia CO2 brine system.
Any more questions on CO2 based refrigeration system? Any questions to be asked through email or anything, because this is a very important topic which is going to be an emerging refrigerant, is going to be in coming years, coming decades. Be in touch with the MyCom people. You can get the card from him. Thank you very much, Mr. Fujimoto. Yeah, thank you very much. Bye bye. Let him go. Mr. Sanjay, you would like to give a small brief presentation about.
I just thought about sharing with you that whenever you are putting up a project, no, there's no PPT. PPT is not there. Okay. Unfortunately, via an email. Sorry. मेरा लैपटॉप में नहीं है, मेरे मोबाइल में था. मोबाइल में है, नहीं हो पाएगा ना. कोई बात नहीं, छोड़ दीजिए. मैं लैपटॉप तो मेल मिला नहीं है उनको. Sorry. See the choice of any refrigerant or so, whether CO2, ammonia, freon. It's very important. Anybody who's putting up a cold storage or a implementer of a cold storage project, that there is nothing as such that ammonia is right or freon is right or ammonia brine is right. It is the size of the project, the type of commodity what you're going to put in the project, and the overall project has to be seen. That is what is very, very important. So what you have to first look at is what produce you are keeping. That is the first important thing. And whether that particular refrigerant system can help you in achieving the desired result in terms of temperature, in terms of humidity. You may find that sometimes freon-based system, in a smaller scale, they may be good. But when you start increasing the size of your project, the ammonia-based system starts going better. So, and similarly, when you look at the CO2 brine system, especially for temperature application of -30, -40 or so, there are quite good systems across to look at. Important aspect for anybody who's looking at this kind of investment is the total cost of ownership. Whenever we go in for designing any facility or so, people only sometimes look at the initial capital cost. They don't look at what is the capital cost, what is the running cost. It might happen that you may spend 1 crore of rupees on your capital cost, but your energy bill may be 10 lakh of rupees per month. While with another refrigerant, you may be able to spend, you have to spend 1.2 crores, but your energy bill is only 5 lakh of rupees per month or 6 lakh of rupees per month. So important aspect is that what is the cost of ownership of that particular equipment, capital equipment you have bought. Not only that, important is the maintenance cost, the spares of the equipment. That's another important feature which one has to look at. You may end up buying a lower project cost initially, but then you might happen that you are investing year by year on expensive cost. Another critical factor one has to look at is availability of the manpower to service those kind of equipment. Fine, you may have one of the finest equipment, finest energy and efficiency, but if the people are not available to service those equipments in that particular area, one has to be very sure that you get the right people across over there. Now, you can end up having the best of the equipment, best of the energy efficiency coming your way, but the people are not there. Either you train the people or ensure that you buy the equipment where the quality manpower is available to ensure that you are able to do it. Suppose you have to fly down somebody from, you're putting up a project in Jammu and you have to fly down somebody from Bombay to service that equipment, the cost of owning that equipment will be high. So my recommendation to the people is first, look at your product, because if the refrigerant is not suitable for a certain product or